if you shine light on electrons, it will be scattered at various angles, and if the wavelength, if the frequency of the light is low enough, you will have first Rayleigh scattering, which is the one responsible for the blue light of the sky. Then if you increase the frequency of the light scattered on electrons, you have so-called Compton scattering, Thomson scattering, which is roughly independent of frequency, the rate. And then if you increase again the frequency of light, if you go to gamma rays, such as the radiation emitted, for instance, by cobalt 60. I did this experiment myself when in a lab when I was a student, right? Then you measure a change in frequency of the light, which is scattered off by electron, which is not explainable in a classical theory. In a classical electromagnetism, the scattered light should be the same frequency as the incident light. The change, the shift in frequency or in wavelength as a function of the angle is described by a precise formula, Compton scattering formula, and this is explained exactly by special relativity as an elastic. Actually, no, it's an anelastic. It's elastic scattering between a photon and an electron. If you use relativistic relations between the four momenta of electrons and photons, you explain exactly this relation between the scattering angle and the outgoing frequency. You cannot explain it classically. You need special relativity. You have a lot of other things. Our accelerators, LHC, which was mentioned before. You have protons, which are accelerated at a terrible energy. They're at energy which is an incredible number of times. It's like more than 6,000 times the value of their mass multiplied by c squared. The energy of the protons. They're accelerated, but they still go at the speed of light. You double their energy, and the speed does not increase. And you measure the speed because you have protons circulating in a 27-kilometer ring, and you measure how fast they go, and they go at the speed of light, 99.99999% of the speed of light. But it's measured. It's special relativity, and the value of the magnetic field that's needed to bend those along that circumference is exactly the one that's predicted by special relativity. You have special relativity all the time. It's proved. And that means that simultaneous events in one frame can be not simultaneous in other frames. This is not intuitive. It's not intuitive, but it's true. It's not that things you don't understand that they have to be false because you don't understand them. They are true. They describe reality. Factual reality.
Franco, okay, bro, okay. You came in here, you interrupted a conversation. We let you go on.
I'm sorry, because I don't hear anybody else. Sorry.
We understand. Hold on, Obi. Hold on. He cannot hear you.
Yes.
Hold on 1 second. We understand everything that you're saying, but just answer me this. How do you feel about the paper that I sent you on the variance of speed of light regardless of GPS by Marmet in 2000?
I haven't read it. But I think it was mentioned some other time. What I say is that if physicists had known for sure and for a verified fact that.
Why, Franco? But you are the physicist, bro. So and I'm gonna let you finish, but then we're gonna get back to the people that were speaking.
This paper would have caused a sensation if it was true.
Franco, I get what you're saying. The point is that you're coming in here hot, interrupting people that you can't hear to talk about something that you believe in. And when you're confronted with conflicting evidence, you choose not to read it. And then you giggle with toxic globe earthers on the timeline about it. The same thing that you were saying you were offended by when we were giggling about the questions being asked to a physicist. So here you are presenting things that you believe in, choosing not to research as the credentialed physicist